There we go. Well, welcome everybody to the SureCall Certified Installer Training. We host this training live once a month, but again, we want to have this available for a lot more people to be able to go to our YouTube site, and we'll review all that later on today here. But we're going to cover a lot. First things first, my name is Eric Mercel. I'm the Vice President of Enterprise Sales. So a little bit about myself. I've been in this industry really since 1992, working for AT&T Wireless. But I've been with SureCall for the past 11 years, and it's been an awesome road to watch SureCall kind of grow and become who they are today, from just a traditional passive DAS solution that we manufactured up until recently, up until about 2 years ago. We started getting more involved with carriers. Few housekeeping items for us is after this event, you will receive a link to all of our trainings and all of our digital assets. So you'll get a copy of this presentation, and then you will also receive a link to our test. Now, our test is open book. We don't, we're trying to transfer as much knowledge as we possibly can to you here. And our goal is not to trick you. That's not what we're looking to do here. So it's pretty straightforward. The test does consist of some true and false, fill in the blank, and some multiple choice. Please note that AI is grading these things, and there are times if we forget a decimal point or a minus sign or a dBm, we forget the M on the decimal milliwatts, the AI is going to miss it. But if you fail the test because of that, we will come back to you and say, this is what we're doing here. So we're in good shape. Any questions you have, you unmute yourself if you want to, but while you're not asking questions, please be conscious of everybody else in the call. Please keep on mute. But you can unmute yourself. You can type things into a chat box. I do monitor that throughout the training. And then for any additional questions after that, of course, you can reach out to me directly. You also meet the rest of our team on here today. But if any questions about pricing or if you want some type of a private demo, the best way of going about it is reaching out to sales@surecall.com. That'll be your best friend for all information on product availability, pricing, how do I get a design done. It's our kind of general email box that our inside and our outside sales team reviews here. So we're going to cover quite a bit. We're going to cover kind of who is SureCall, give you a really good understanding as to a brand story, as to why choose us over our competitors. Why partner with us? What are some of the assets that we bring into you or some of the services we bring to you? We're going to get into what is DAS, what causes weekend building cellular coverage, a high level product overview of our traditional or legacy products. We're going to spend a little more time talking about some ultra wideband 5G, hybrid fiber systems, and really that evolution of what DAS really has come to today. And then we're going to get into the meats and potatoes of really how do we get started? What is the first thing we need to do with a site walk? Is there work prior to that? And then we'll cover, again, some of the installation techniques and then what we have to do at the very end for commissioning. So without further ado, who is SureCall? Well, SureCall has been founded in 2001, and we are based out of Fremont, California, although we have offices in Atlanta, Georgia, Chicago, Illinois, Toronto, Canada. And we also have a Utah office as well, right out of St. George. So we've got a lot of people in different places, and it's pretty important to watch our team grow this way. And since we started, we've always been in the enterprise or commercial space. Some of our boosters that we still manufacture are some of the larger scale boosters that can do 500,000 square feet off of one solution. But we've evolved, just like all of us have to. We've evolved, especially around that COVID era where we've done a lot of in-building products for more of a DIY channel. And one thing I will put on a totem pole for us here right now, we're on a pedestal, is the products that you see on Amazon, like our Flare, those very top products that you see on the in-building consumer, they do not compete with the enterprise products. Our enterprise or commercial grade products are not for an end user to go install. There's a lot more to it. They're more complicated. So you don't have to worry about somebody saying, hey, I want to buy your hybrid fiber DAS system and going on Amazon and finding it for cheaper. We don't allow that practice to happen. But we also evolved into our in-vehicles. We do a lot of fleet opportunities, a lot of government work with that. FedEx and UPS, for example, use our products, especially in their more rural areas. And most recently, about 3 years ago, we started working with the carriers, and that's one of our biggest differentiators between us and our competitors is we truly have product that they're taking and utilizing it on their network. So outdoor amplification. Verizon and T-Mobile specifically are utilizing our products on a very regular basis. Benefit of that is if we've learned how these networks work, I think more so than a lot of our competitors in this space. And it really allows us to take that technology from what the carriers see important and build that into some of our newer products like our 5X Max and our hybrid fiber DAS system that we'll cover a little bit. So it's been a really awesome journey to kind of watch SureCall navigate, and more important, I think having an owner of a company that is willing to take the risk on the next technology and the next adventure, and not just sit status quo within our space here. Now, all the boosters we're going to review today are all FCC and carrier approved. They are what we consider a Part 20 solution, which is a legal booster in the United States. And to be a legal booster means that I don't have to go get retransmit agreements with the carriers. I don't have to work with them to get spectrum because we're borrowed it off of the network itself. Now, to become a Part 20 solution, you do have to have some network protection features, automatic gain control, oscillation detection, excuse me, detection and prevention. And then we also have to make sure that our boosters aren't impacting the tower. So a lot of our uplink controls, the signal going from the boosters to the network itself, they're truly monitored remotely so we can ensure that we're not going to have those problems. Now, what does a Part 20 booster really mean for you? That means that we can deploy them really quickly. They're very inexpensive when it comes down to the grand scheme of things. And on average, we're less than $1 a square foot. And that would be a turnkey cost, labor and um, products itself. And then you don't need to bring any additional fiber. So you don't need a head-end unit. I don't need a base station from a carrier because we are pulling everything off the network itself. Now, we do offer design services. You can go to SureCall.com, and the very bottom of the page, you'll see design services, kind of in the fine print area. But that design service support area allows us to be able to pull these projects together for you. So we'll give you a heat map, and then we'll also provide you with a list of materials. And then if you need data sheets, that'll be in the link after this training that you'll have all of the marketing documents that you would need to put your bid packet together. Speaking of marketing, we also do a lot of co-branding products. So if you have an opportunity where you have maybe a website, you want a banner, if you have some leave behind, maybe it's a trifold and you want to put SureCall on it, you can reach out to us and our marketing team. And it takes about 2 to 4 weeks, but we can help put together a nice little marketing program for you as well. And then, of course, our tech support team. You have our sales team that are pretty in depth. We understand the product and what has to happen. So at a basic level, we can kind of guide. But our tech support team is based in Fremont. They are there to support and help you. So feel free to reach out to them at any time, and you'll get their number at the very end here as well. So our team, we wear a lot of hats, and we work very hard with each other. So in the US, we do have Ken O'Connor, who's based out of the Atlanta market. He runs our East Coast tech side of the equation. Dustin runs the mountain states and everything west. And then although we all work together, I also manage kind of the sales in that central part of the of the country itself. So we've got a lot going on that's out there. We also have manufacturer rep firms in each one of these markets that can be an extension of our team as well. So we'll be able to share that information as we grow our relationship together here. So what is DAS? Well, DAS stands for Distributed Antenna System. And why do we need this within a facility? Well, everything reflects or rejects the signal, everything that's out there. If you're talking to somebody with new construction and you're having a conversation in regards to, you may want to look at cellular DAS for your building, and they're standing on a pile of dirt before they even put the walls up, and they're like, "No, I got 5 bars. I'll be fine. Don't worry about me." And then as soon as they put the windows in, the roof goes on, and they start putting some walls in the inside, their signal drops drastically, especially if you're using low E glass windows. That is the biggest culprit that's out there. It's 30 to 35-ish dB worth of loss, which means if you have 5 bars outside, you might only get 1 bar inside. So it really drops significantly once we start looking at the building materials themselves. But it's not just the building materials that is the largest culprit, and it is one of the test questions, the largest culprit that's out there. We also have to take into account terrain and how far we are from a cell tower. Now, terrain isn't just like in the picture here, where it's mountains and trees and valleys and whatnot. It's also, if you're in an urban area, what other buildings are around me? If it's newer construction, let's say you're in Nashville or in Fort Lauderdale, where there's a ton of building going on, you might have an open plot with nobody next to you, but what happens in 3 to 5 years? Where are those cell towers located? How far away are they? And if the bigger building comes next to me, how is that going to affect my signal? Because remember, everything reflects or rejects away from it. And a big steel building with concrete walls or metal siding on the side of this thing is going to reflect that signal away from you. And then the distance, really, especially if you're in a more of a rural area, the further away you get from a tower, it's not a lot of the signal can't get to you. The towers can get you the signal. It's the output power of your cell phone on the uplink side that has a really hard time getting back out to the network itself. That's where you run into a lot more of the drop calls. You just can't maintain the connection. So that's where a booster solution or a passive DAS solution will really come and help. And there's a whole plethora of types of DAS out in the marketplace. There's stuff for small buildings, big buildings. There's hybrid solutions. So let's look at just kind of the first step here, a traditional DAS system, more of our passive solutions. This would be some of our legacy products that we still manufacture, are really good for those 50,000 square feet and below, which, believe it or not, is a huge portion of our marketplace. But those solutions that are out there are those quickly deployable networks, and those are even cheaper than looking at some of the hybrid or 5G solutions that we bring to the market. You're typically under 50 cents a square foot for a turnkey. So I bring that up and cost association with it because there's a lot of customers that will say, if you bring up, hey, we have a cellular DAS solution, they'll say, yeah, we've looked at it, we can't afford it. They're probably thinking of active DAS. Active DAS, by far, these carrier grade systems are the gold standard in the industry. The biggest reason why the carriers love these things is because it helps offload users on their actual cellular network. So you'll see these systems in large hospitals, like a Mayo Clinic up in Minnesota. You'll see them in large resorts or skyscrapers. You'll see them in convention centers. And these things actually have the carrier, essentially, which is called building a tower within the facility itself. And it's important to the carriers because there is a capacity limit that every cell tower will have. And I'm sure we've all had those issues. Even if you go onto a cellular DAS system in an arena or a sporting complex, that you go to make a text message and the little green or blue line goes really, really slow, or you go to make a phone call and it takes a little bit longer for it to connect. It's not your phone isn't working, it's just there isn't enough coverage or enough capacity within the facility. So now compound that. If you have a tower outside your building and that tower right along a highway has great service at noon, but when rush hour hits, you start running the capacity issue, that's going to affect your large building drastically. If you had 3,000 people inside the building and another 4,000 people outside all pinging off that same tower, you're going to run into performance issues. That's where the active solutions come into play. Now, the drawback to them, as I'm sure you've already read way ahead of me, is they cost a fortune. And this is where a lot of the customers say, we looked at it, we just can't afford it. It's not only the cost of the product, it's the installation, engineering costs. There's carrier integration, which is anywhere between $50,000 to $500,000 just to bring the network to the building. And there's ongoing costs with them. But sometimes that's the only way to do a proper DAS installation. Competitors, which I'm not scared to talk about them. JMA is probably the number one that's out there. You also have Corning, you have CommScope, and there's a plethora again of other partners. But I think those are the best three if you're looking for very, very large buildings. But SureCall fits into that mix as well because hybrid solutions are very important. Now we can have a cost solution for a smaller facility, about $50,000 all the way up to about 350 grand. But now we can scale a system very similarly to how a standard solution, how an active solution would work by introducing fiber into this. So our hybrid solutions, which we'll spend a little bit more time on in a little bit here, are really the next generation of solutions that are out there. So this market is growing significantly. Currently, actually last year it was about almost a $10 billion industry. And within the next 3 years, they're expecting it to grow to about $13 billion. And it's going to continue to increase. Now, the reason for it increasing is we're all used to it now. Everything is wireless. And about 90% of all phone calls on a wireless network are made indoors. Think about that. We're not necessarily using them all the time outside. They're always inside. So it becomes a huge factor in retail. It's a huge factor in customer experience. In healthcare, everything's app driven. You walk into a building, yes, you and I maybe might have a technical advantage because we work in technology, but we can connect to a Wi-Fi network. There are a lot of people who won't understand how to connect to a Wi-Fi network, so it takes away from that experience. And as technology continues to grow, the speeds are going to get faster, the frequencies are going to get higher with 5G. The higher the frequency, the less it'll penetrate a building. So carriers are now looking at this as connectivity is really that fourth utility, meaning that they will get the signal to the building, just like the electric company, water company gets everything to the building. And it's up to the experts, you guys, to be able to pull that signal in and install a proper solution. And then we take it even a step further. Public safety requirements, the Safer Building Coalition, or SBC, is looking at how they can help increase in-building connectivity with a campaign of 911 inside or 911 everywhere. Because honestly, with people having cell phones in their hands, it's a quicker way to get those emergency responses that you need instead of running to a landline phone that's out there. So we do see a lot of increases in coverage and activity. Education, K through 12, by far our number one growth category. Data centers, close second behind it. And then we get into the hospitality like hotels, healthcare, and carrier sales. It kind of rounds out our overall market. And we look at 5G, 5G continues to grow. You just look how fast we've gone. I mean, we're in almost 500 now. This is a little outdated. I think we're over 500 markets that bring ultra wideband 5G into the mix here. And the carriers want 5G so bad because it's like a 20-lane highway versus our 4G or LTE, which is like a 6-lane highway. So there's more capacity. They can put less equipment on the towers and be able to handle more users that are out there. And 5G is important. If I just look at how the technology's advanced, right, since the late 70s all the way up to today, the one thing that holds true here is everything is evolving. So 4G replaced 3G for voice over LTE, which is a 4G network, is going to be replaced by 5G, voice over 5G. So how do we future-proof an installation? I really think voice over 5G, you're probably 5 to 8 years down the road before you start seeing carriers take advantage of the network. They got to build it first, and then people will come onto that network. But 5G can be confusing. And one of the questions that has already popped up here is, does your system work on 5G? And the answer is yes. But what type of 5G, right? So there is nationwide 5G, is what I like to call it. And if you look at your phone and you're not on a Wi-Fi network, typically your phone will say 4G, LTE, 5G. If it says one of those three, you are working on today's LTE network. Essentially, they have given you a band, or they've dedicated a band for a faster, more robust data experience. Now, all of these frequencies in our 5G are under 7,000 megahertz. It's going to be important future conversations here. But all of our boosters that we manufacture today will work on all of today's 4G, LTE, and nationwide bands. So yes, our boosters will work on that. Through what they call dynamic spectrum sharing, just to be able to roll 5G out a heck of a lot faster into these marketplaces, we are able now to go to ultra wideband 5G. So remember the conversation we just had of if your phone says 4G, LTE, or 5G, that you're on the nationwide or the LTE network today. If it says 5G plus, UW or UWB for ultra wideband, then you're on a different frequency. And that's where we're seeing almost a gig download speeds. It's actually a little bit quicker than that now. But this is C-band, which is rolled out nationwide for most of the carriers, that starts working on that 3.7 to 4.2 gigahertz range. There's somewhere within that space there. So this technology is not built into any consumer booster that's out there in the market. But SureCall does have a product that'll do all C-band frequencies for AT&T and Verizon. And we'll talk about that product in a second here, but I promise you it changes the mentality of how people look at how we future-proof. Is there an additional expense to adding this? Yeah, just like anything else. If you had a 1080p TV, now you want a UHD television, ultra high definition TV, you have to buy new hardware. And this product will drop right into our existing infrastructure as well. And then you got millimeter wave, which is a whole nother set of ultra wideband, but we're over 24 gigahertz in coverage. I think we're at 37 and 39 gigahertz now. And this technology is really used for that 5G at home, 5G for business, where you can buy a router and you can see almost 10 gigabits of download speeds for about $50 a month. If you've got it in your area, get it. It's awesome. We run our whole house, the 2 kids, college kids, gaming, homework, the whole 9 yards. It works flawlessly. We have AT&T. So that's a little bit about kind of who we are, what we're getting into, the marketplace itself. And when I look at the technology and the boosters we bring into the area here, our traditional passive dash solutions that we manufacture, everything from the Force 8 to the left, all that technology is our traditional, meaning that it's standard copper layout, where you have a donor antenna on the roof. That donor antenna will go into the booster, and then from the booster, you will distribute your coverage out from there. So all those boosters are great for that 75,000 square feet and below. And that turnkey cost depends if you want ultra wideband or not. You can just, on average, you can talk about $1 per square foot. And that would be able to provide you all the cabling, the tooling necessary, if you need J-hooks, if you're in a commercial space. there's like 5 questions that popped up in regards to cabling, and we'll get to that, I promise you. I'm not ignoring them, I see them there. So looking at traditional passive DAS, it's been the mainstay for the past 20 some years. This is just how they were manufactured. But one of the changes that we made is what we consider a game changer in the industry. We call it extended range technology, or ERT. Now, ERT has changed the architecture of traditional DAS just a little bit, but it allows for just a better user experience. It has better coverage, better connectivity and range, and better data performance. And ERT changes because we actually mount the amplifier on the outside of the facility. So you are directly connected to your donor antenna. Benefit, it's one of the technologies that we learned by working with the carriers, but specifically with working with ultra wideband 5G, is it allows us to have the maximum amount of a power that the FCC allows, that full 1 watt, out from the booster to the tower itself. So I can reach further. So I can go deeper in those rural areas, or cottage country, if we want to call it that, to be able to provide better coverage. Plus, it also preserves our SINR, or our signal to noise ratio. Signal to noise ratio is something that is detrimental to any DAS system. If the noise is too high, you can't get the performance out of it. You might be able to make phone calls, but you're not going to get a lot of the data performance out of it as well. So this booster is really slick in how we go to market with it. Does not require any power to the outdoor booster. It's all done over coax cable, and we do use our 50 ohm cable here. Once you go from that output, the outdoor amplifier, that will now reach into our control module, which is on the inside. And that control module has changed a little bit, but it has, if you look at the bottom of that gray booster, it has 2 ports on it. Now, both these ports are the max allowed by the FCC, so it's 17 dBm of power. And this one booster can be scalable up to about 75,000 square feet. Some things we have to change to make it happen, but cabling and accessories, but we can stretch it that far. So for right around a $7,000 price point, it can do a lot for that particular booster. Market has changed, as we talked about in the very beginning, that SureCall evolves quickly. I think we're the leader when it comes down to product development, especially when we create it ourselves and we don't just go out and buy another manufacturer to have a fiber solution. But hybrid DAS is important because over 42% of all the installs last year were a hybrid fiber solution. And all the same requirements still live in it, right? The education, all the top growth markets are the same. So I'd like to introduce to you, if you haven't seen this already, our Signal Max fiber DAS system, which is the first FCC Part 20 hybrid fiber DAS system on the market. So this is, again, it's all FCC Part 20 approved, so you do not have to worry about a Part 90 booster, which you have to go get carrier retransmit agreements on. And just be careful how some manufacturers are out there doing it, because they'll feed it with a Part 20 system, but it's still Part 90 inside, higher power, and you can get in a little bit of trouble with that. We've also rolled out our new SureCall cloud monitoring system. Does require fiber from the master unit down to the remote units. But more importantly, we listen. We listen to what you're saying, and we have a Bluetooth app now that really helps you align to make sure you get the best coverage you possibly can inside. And I'll show that here in a second. So the master unit, the way these systems are sold is you will get a master unit kit. We call it the MURU, or master unit remote unit kit. So the master unit that we're showing here does have 4 ports, 4 fiber optic ports. Each one of those ports will connect to a remote unit. So this booster does get mounted outside, directly connected to our donor. So we have extended range technology. And you can see that diagram down below, but essentially we're running fiber from that master to those remote units. And for right around $13,000, you get the full kit that you see on the screen here: a couple indoor antennas, some bulk coax cable, fiber, a remote unit, and the master unit. So it's pretty unique in how we go to market with it. And then we can add, to expand that system, we can add up to 3 additional remote units. Each one of these remote units will cover about 125,000 square feet and has all the same Bluetooth technology built into it as well. So a really unique way of going to market. The biggest benefit of this product is I no longer have to run copper from the roof where the donor antenna is at all the way down to where the boosters or remote units are at. Remember, increasing sign, or making sure you have the best signal noise ratio is possible, is going to help us. Having the best signal strength coming into these boosters, the remote units, is going to help you expand coverage even beyond that. Where we see a lot of our partners utilizing this now is having a warehouse. Maybe it's a 1 million square foot warehouse manufacturing plant. You could put one donor roof penetration on the far west side where all the antennas are at, and then run fiber now to each one of the remote units. Traditional DAS, a lot of our older products, you can't do that. You would have to have a roof pen all the way down the line for some of these larger facilities. Or maybe it's a high-rise facility where you're up on the 40th floor and you've got to run copper down to the maybe the second or third floor. Those cable runs get really long. And when you get too long, you've got to go bigger cable. The bigger the cable, the harder it is to pull. So fiber really makes it easy to go from your donor to the inside and solution itself. So a very unique solution how we go to market with it. But once you're in the remote unit, it all works just like a traditional DAS. It's all copper from the remote unit out to your indoor antennas or your server antennas. So it just becomes more of that traditional side from the remote unit down. But it's different. The hybrid system is from the master unit into the remote units. The app itself is really slick. Go to the iOS store, the Play Store for Apple, or your Android store and download the SureCall app. It's really a slick app that once you're in the building, especially if you're up on the roof and you're running it by yourself, you can log into the Bluetooth app once you get power. You can align the donor antenna to make sure that all the carriers are coming in equal strength. And then you can lock that thing down and then go back into the building itself, connect to remote units. So it really helps you more on the step-by-step installation side of the equation here. It's got the signal meter built into the device itself. So no longer do you have to walk around with 3 different meters. And it's so easy to use. So I highly encourage you all right now to go into your app store, download the SureCall app. It's once you've got this thing rolling, you'll really enjoy it. Now this is available on the 5X Max as well. The ERT booster that we discussed. So the 5X Max, the Signal Max, and then also our ultra wideband solution itself, which is our SpeedLink solution. So the SpeedLink solution is our first 5G booster that is truly approved by the carriers, by both Verizon and AT&T. Now we do ship this out as a Verizon only spec, but we can over the air, we can turn the system on remotely. It will support the whole ultra wideband or the C-band frequency sweep, and it can be installed as either a SISO or a MIMO solution. So what is SISO? Well, SISO is your traditional single input, single output. That's just one cable running from the roof down to the booster to your antenna. It's just one cable. MIMO is multiple in, multiple output. And what this allows us to do, just like our cell phones have 2 antennas in there, one for send, one for receive, this allows for about 37% faster speeds, almost 40% faster speeds coming out of the booster. Now, it does require a little bit more labor, so it does raise the cost a little bit on the installation side of it. But this is, if you truly want a future-proof technology, adding our SpeedLink with any of our other boosters and then running it in a MIMO installation like this will really allow you to set that customer up for the next 10 years without having to touch anything within that facility itself. So it's a really slick system. And as we sit there and we look at how we can deploy these things, I know it looks like a big spaghetti mess. You can either do a standalone 5G solution with the SpeedLink, or you can integrate them in with the 5X Max, really any of our boosters. I just use the 5X Max here as an example. But it's a very slick solution in how we go to market with it. And then for remote management, for anybody who does any type of a monitored system, or you're doing recurring revenue or a service contract, we do have a new cloud management system here that is completely offline, meaning that it does not have to connect to anything that anything that the customer's network inside their store. So I don't have to go into their Wi-Fi at all. It does have a Cat M1 integrated modem and allows us to really capture a lot of the performance metrics within the system itself. Keep in mind, it is free for the first year, and then it's $150 a year after that. We don't publish this price to anybody else. So your cost structure is $150 a year. We will bill you on an annual basis, and then you can turn around and bill the customer if they want to have management of the system itself. If they don't, we don't have to turn it on for you. Now, when we look at the actual cloud solution itself, there's a little bit of setup you have to do. So 2 things I would encourage you. Make sure you have the serial number available when you call into tech support. There's a little silver sticker kit that comes with it. Put that on your paperwork. Make sure you have it. It'll just save you time and not have to go back and forth. But when you call our tech support team, they will ask for a credit card. It won't be charged. It won't be charged, but you'll get notice of 60 days, I believe, before we would. And then you can either say yay or nay, I want to move forward with it or not. But you'll go in, you'll click in the login information at the, let me go back here. It's at the SureCall-Cloud. That link there will get you to the actual .com site for you. Once you're there, you're going to log in. just click the login button, create your username and password. You'll be logged in at that point, and then easily we'll be able to go through the dashboard and we can start adding different boosters. Now, technically, our design team, or sorry, our support team does this for you. But if you do have the booster ID, which is simply the serial number, we can plug that in there. The authorization code, which our tech support team will give you, and then we can just add the device into it itself. Once it's been added, now we can go into this, we can actually edit it. So let's say you had multiple buildings, multiple customers, and they have boosters throughout the facility. You can label which room, which building it is, so you know if there is an issue with the system, which customers have any issues that are out there. Now we can actually see a lot of information on here, and we're just going to spend a little bit of time on this, but it's important to note that we can actually see the uplink and the downlink side of the equation on here. So when I click on my boosters, I can actually click on the name of the booster itself, and now I can get into the actual kind of, let's call it the heartbeat of the system. I can see how much power I'm receiving. I can see how much output power I'm putting out into the actual building itself. More importantly is it's real time. So I can do this on an hourly basis, a daily basis, a weekly, monthly, quarterly. But it's really important to look at when we talk about capacity. If you're having a customer that's just having a subpar, um, they're just not getting the performance they wanted out of this thing, we can actually go in there and see, is it all carriers dropping out? What would the issue be? Could it be a carrier phasing their antenna from where it's pointed on the neighborhood to maybe just dedicating it for a tower during certain times? Potentially. But we can now see how that system works. And not only on the downlink, but also what the booster is sending up to the tower itself. And then we can actually see the capacity side of it. We're the only ones that can provide this. This is so important. As I can tell you with passive and with the way networks are becoming more congested, it's not that it's a huge issue, but when it happens, it's very difficult to identify. So having a capacity, being able to see what that tower and what the network, how they're talking with each other, is pretty unique to the marketplace. So it's definitely something to keep in mind when you're installing the systems that are out there. Now, there's also some other options that we can do with these systems. Going through the settings side of it, I can go in here and actually edit the booster, so I can change the gain. I can override my automatic gain control. I can set different power limitations on the downlink, and I can set attenuation limits on the system itself. And this is all stuff you can do remotely. You don't have to be in the market itself to do so. Once I save it, I can actually go and reset the booster remotely. So it's just, sometimes you just got to give the thing a kickstart, right? Just like an iPhone or anything else. Sometimes a reset helps everything. We can do that now remotely. You're not having to roll trucks. So for the $150 a year, it's a really good performance add-on that you can offer to your customers and really help maintain kind of your expertise in the space itself. Now, if there is an issue with the booster, we can actually monitor how that system works. We can actually see how, I'm sorry, if there is an issue, you'll get an alert to state that said problem is happening, whether it be oscillation, antenna disconnect, or even a power failure on the system. You'll get a notification. You can label up to 5 people, and you can set admin rights, so maybe they can just view, or you can have full access to it and adjust the booster as needed. But a lot of times these IT directors we work with, they want to see how the booster is working and they want to have some visibility. So I think that's something that you could offer to them as well. I don't know if you necessarily want to give them the alerts to say, hey, there's a problem with the booster. But this will definitely at least be able to advise you if there's a problem or not. So that's a little bit about our product set itself. And the reason why I don't go into too much more detail on each one of the products is everything's going to be just a little bit different. There's really nothing cookie cutter about a DAS system. Yes, the head end units or the boosters will stay the same, but everything else in between is going to be changing here. I do want to give an honorable mention to our mobile products that are out there, our fleet. I'm not going to go through these things here, but we got them. We'll move right on. So again, what product's right for your customers? Well, that's really going to come down to design. It's going to come down to where you're at, what type of technology is available in the marketplace today. So we're going to be jumping in and out of this presentation a little bit today. We're going to talk about the site survey and then that system design, and then we'll get into the installation side of the equation itself. So your best friend in the US will be cellmapper.net. Write that down, make sure you've got it, because cellmapper.net is so important to look at. And we're actually going to jump out of this really quick, and we're going to get us set up here at cellmapper. And I just want to show you a few things on this technology and why it works so well. and how you would actually want to use this technology kind of moving forward. So give me a thumbs up if you see it. Awesome. Thank you. All right. So cellmapper.net, it will become your best friend. And before you even go out to the sites, it's always best to have some type of idea as to what you have to inspect. So let's look at T-Mobile first. We'll start with their 4G network. And I'm going to let's just pick this. Well, that's too close. Let's pick this parking garage over here. This is what kind of our point of interest. This is where the customer says we need coverage here. Few things right off the bat I want you to look at. There are a couple different icons on here. A tower like this, although it looks like it's the closest one to us, this is an actual DAS system. And when you register your network or your boosters on the carrier's network, a lot of times they will populate something like this. This is not anything we ever want to point towards for a signal source. It won't have the capacity for you. The ones in green mean that they have been verified. The ones in red are probably there. They're just not verified. The other thing you look at here are the different bands, 2, 12, and 66, 2 and 66, band 41, and then you click below it, and it brings up a bunch of other, come on, work with me, not against me today. It'll show us all the different bands that are on here too. So like band 66 down in this neck of the woods. And band 66 is a very, very important frequency spread for our carriers. All of them are using it right now, and SureCall boosters do enhance band 66 now. So let's click on some of these antennas here to see kind of what the area that we're looking at here. So this is a free site. I don't pay for the non-ad one, and I use it every single day. So you don't have to sign up for the big deal on it to pay for it. All right, so parking garage, let's click on the first tower. And one thing you'll notice is the towers are not like a big umbrella like they show on the TV commercials that are out there. They are very directional. They're aimed to be able to cover different areas. Does it mean that this tower isn't a good tower for us? No, it just doesn't necessarily cover this particular area if you're walking around on your cell phone. There's going to be other towers that are out there. For example, this red one that we clicked on, you can barely see it, but it pulled up kind of a point to point almost. So this is actually feeding this DAS system. So that red one is there, but it's not for us to use. But a lot of times we're going to go around and we're just going to click on different networks. You can see this is another one. This red one is just point to point. These little green lines picked up here. And T-Mobile's got some pretty shoddy coverage in this area. Let's go up to this one and look. That's band 41. What about our 66? So if for T-Mobile, you have two options. We have our tower down here we could use, or potentially the one to the northwest would be a little bit better. Now, once you click on the network itself, a few things you want to look at and take note of is, give me a second to go back to this. There we go. The bands and frequencies that we want to enhance are right here. So when you go out with your signal meter and you want, or using your cell phone, please note that your cell phone gives you your carrier. So you would have to have all three to do a proper assessment with your network itself on your cell phone. But if you have a meter, you want to write down the downlink frequency only, 2145, and then what band they're on. And you're going to do this just across. You can see there's a lot of, right now 2145 is the primary frequency for T-Mobile in that area. But there's also 1970, band 2. 1970, band 2. There's 731, band 12. 731.5 again. 2162, band 66. Another 2160. I know I'm going a little faster, but you get the general idea. These frequencies are going to be your important things that you want to inspect. Now, when I switch from this and I go to, let's pick on AT&T 4G right now, you can all of a sudden see that they don't share towers very well in this area here. So in this particular scenario, we want to make sure that we're clicking on the right towers. And right off the bat, I can tell you that you're going to want to, in this particular scenario, you're probably going to want one donor going up to T-Mobile and another donor going over to the AT&T networks that are here, just to ensure that you got proper coverage coming between them. And then you're going to go through and do the same thing. You're going to look at the different bands. So 800 megahertz, band 5, 1900 megahertz, band 2. You'll start to see that the carriers are all utilizing the same frequencies or very similar frequencies, but they're just on different bands. It's like band 12, band 5 again on 800 meg, and then band 66 on 2100 meg. What happens when I go and I look at Verizon now? I'm going to click on Verizon Was that Verizon I just did? No. So Verizon has a tower right next to us. Well, I'm sorry, that's not, that's a DAS system. Verizon's going to give you some trouble in this particular scenario. This is a great exercise to look at. So their tower that actually covers the area is much further away. Hence, why you see so many DAS systems in this area is because the coverage isn't the greatest. So when you go out and you do a site survey, you're going to start recognizing that the output power of the tower being further away, there's something that we call near far. And this is where multiple donors on a roof will come into play. Remember, so Verizon's up here. T-Mobile from our building was up by Northwest 3rd Street here, and then AT&T's best tower was down here. So when I start looking at near far, because the carriers utilize the same similar frequencies but different bands, T-Mobile being off to the left, we would have to aim one of the donor antennas, a directional antenna or a Yagi, from this our donor site to the T-Mobile tower specifically, and then we'd have to have another one that we would aim towards that Verizon network, and then of course one down to the south here for AT&T. I would not use an Omni antenna in this scenario, simply because an Omni antenna, you would run into potential issues with all the noise in the marketplace. So I'm glad this one popped up for us today. They're different every training, but this one here is a great example as to utilizing this to find your networks, find your towers, making sure you have the right frequencies. And then when you're up on the roof and you have your donor, you have your antenna and your tool, your meter, you can actually do your sweeps to find out where everything's at. And if you're sending this out to somebody else, maybe you're farming it out to another integrator company to actually run the cables and do the install, which is fine. It happens a lot. We can make sure that they know which way we got to point these things. So Cell Mapper is going to be your best friend out in the marketplace itself. It's really unique in how it actually pulls things into our the equation when we do a site survey. Any questions on that? We'll take a quick stop here. Any questions on some of the products that? No? Okay, good deal. Good deal. Here, I got this one here. Continue to share. Good deal. Hopefully y'all can see that again. It looks like you can here. All right. So how do we find the outside signal? Yes, you can use your phone. Again, you have to be a little careful with it because it's only your carrier. We do manufacture 2 different meters, and we have a brand new one that'll be coming out that'll be Bluetooth driven that we're really excited for. We'll probably see that Q4, but it'll do a heck of a lot more than what these two do. But these two solutions that we have are very inexpensive. We actually sell them. The red one there, the 4G LTE solution, is $150. Normally, I think it's 400. We're doing it for $150 with a coupon code. If you're interested, just email us and we'll get you the coupon code. And the C-band meter, I think, is $200. That was normally 700. So the goal is to just get you the tools so you can do the proper stuff that's out there. Now, there's a couple different ways you can read the signals. RSSI is Received Signal Strength Indicator, and that's mainly what our meters give you. And it gives you the total received strength, the power coming in, including the signal that you can actually tune this thing to your specific frequency and or band that's out there. Your cell phone is going to use RSRP, which is the reference signal received power. It's a little different in how we go to market with that. That's a great question, Andy. So the C meter cover, no, it only does C-band. It doesn't do both. So you would need both of these meters. And then yes, the SpeedLink uses passive splitters, and we'll get into that here in just a second, a little bit deeper. So RSRP is the received power. So your received power is about 30% weaker than RSSI. So for example, if you have a neg 70 RSSI, you probably have closer to a neg 100 RSRP. Keep that in mind. Neg 100 RSRP is actually a good signal to be able to utilize. And then your phone and our new meter down the road here will do RSRQ, which is a reference signal received quality. And it combines both RSRP and RSSI together, and it gives us that reference number. So the lower the RSRQ, the poorer the quality, which means that you're not going to get very good data signal on the inside of it. If you are going to utilize your phone, and really in iPhones, iOS 13 and above, you can just dial this number, that star 3001 pound 12345 pound star, then you hit the call button, and it will actually put your phone into a test mode, and you'll be able to see RSRP, RSRQ, and you'll also be able to see the signal to noise ratio or SINR ratio that's out there. So pretty unique again on how those phones will do it, but remember, it only gives you your frequency. And then Android, you can do it as well. Android, because there are so many different operating platforms from Samsung to Google to you name it. A lot of times the star pound number 2 here, a lot of times that doesn't work on all the phones. So you really have to go into phone information and kind of scroll your way through it. But those alternate paths really allow you to do a little bit more with Android than you can with a Samsung. I'm sorry, with a Apple phone. Now, really quick on these meters. So the SC Meter 01, which is the red meter here, this will do all of your frequencies up to 2700 megahertz. So it'll do all your voice and data frequencies and nationwide 5G. The green meter will only do C-band, as we mentioned, and it's pretty unique. On the red meter for LTE, there are different modes. Mode 1, I can go and look at the different frequencies by block. Mode 2 allows me to go by frequency, so we can actually dial it in and get to the network frequency that they're using in that marketplace. And then mode 3 gives you an aggregate of all the frequencies and all bands in that area. Why we do that? It's simple. There are times when you're talking to a customer and say, hey, can you help me with this? And you just didn't have the time to go do all the homework. At least you can get a baseline to say, yes, I can make it work, and go back and do the homework and then come back to the building itself. One little trick, cellmapper.net works wonderfully on your cell phone. And actually you can pinpoint yourself and then you can just start pulling into different carriers. The interface isn't the easiest to use, but it is pretty simple to use overall. Now the 5G meter itself has the same setups with mode 1, mode 2, mode 3, and it just breaks it out from RSRP, RSSI for just the Verizon and AT&T numbers. The reason why T-Mobile is not in this is because T-Mobile does not have a C-band network. They use a different frequency spread that's out there. So why is this so important? Well, we know that signal strength matters. And when I look at kind of the sweet spot, if you will, RSSI sweet spot is neg 45 to a neg 85. Does that mean that the system won't work if it goes weaker than that, like a neg 90? No. It just means that this is where we want our boosters. This is where everything loves to sit there and hum. Unicorns, pixie dust, and rainbows are outside right now. RSRP, you're usually between a neg 44 and a neg 120. So neg 120 is really poor, but we can still make a system like that work. RSRQ is an important one that only your phone's going to give you right now, but the higher it is to neg 20 is the better signal. We want to make sure we're up and around that neg 15 and above really is where I want to be at. So regardless, all of these values are critical for us, and it's really important to see how this actually affects the performance of the in-building coverage. So we're going to use 1900 megahertz. It's a popular voice network and data, but it's that mid kind of level between our 700-800 meg and all the way up to 2100, where it travels, but it doesn't travel as great as we would want it to in a building itself. So 1900 megahertz, mode 3, neg 60. In this scenario, we have 2 boosters running off of 1 donor. So we're running that donor from the right side. You're going to see how the system on the right of this drawing is a little bit hotter. And then we run it into a 2-way splitter to go from the system on the right, 160 feet roughly of cable to the system on the left. That's why there's such a drastic difference already. Every 100 feet on 400 series cable, we're losing about 7 dB roughly. So it's pretty significant. You run it through a splitter as well, you're losing your almost 10 dB loss before you even get to the booster. Watch what happens when I go from a neg 60 to a neg 80. Still usable. I go to a neg 90, the system on the left is not going to perform the way that the customer would expect it to. So you would have to utilize a second donor antenna closer to this booster, or increase the cable size. Maybe you go to a 1/2-inch cable for your donor run. I get to a neg 100, the system on the left doesn't even have enough signal to be able to boost. And even the system on the right doesn't have the performance we're looking for. So again, can we make it work at a neg 100? We can, but it's critical coverage areas only. I would never offer anything for a full building solution. It's, hey, it's going to go 1 antenna right up here in the gathering area, and we can make the system work, but you're not going to be able to handle a lot of callers. So it's so important to really understand that the lifeline starts with the site survey. I need to know what that signal strength is. And if you don't have time to do it and you just kind of guess and says, it's probably a neg 70. And we put the design together for you, it may not perform the way that we need it to. So the signal meters themselves are crucial to be able to get at least your base starting point before we even decide to move forward with it, especially in a larger rollout. If it's residential, it's pretty simple. I mean, you don't have a couple hundred feet of cable runs that are out there. You got a very standard system. So any questions on how do we find the signal, frequencies, anything like that? There's a lot of uh, questions coming on in regards to the cabling and installation. We're coming up to that now. All right, let's keep moving. So step two, we've done the site survey. We understand kind of where we're sitting with the customer. The customer is, yeah, give me a budgetary quote. So now we're going to go through and make sure that we understand that a booster that says it can do 125,000 square feet, that's open space. That's a big manufacturing plant. You don't have a lot of things in the way. Maybe it's a convention hall with a lot of wide open spaces. But once you start adding those walls back into the equation here, things are going to shrink pretty drastically. So if you look at drywall, -2 dB in your standard 1/4 inch drywall, you lose that neg 2. Every 3 dB, my coverage shrinks by half. So a booster that claims it can do 125,000 square feet may have more than those standard 4 antennas that typically come in a kit. You might have 15 antennas because of the architecture of that house, the building itself. So that's important to understand because when you go to surecall.com/designs, there are a series of questions. A lot of it is your information. And then in addition to that, we have to make sure that project name, address, signal strength, what are the walls made of? Be as specific as you possibly can of it. If you're in a school, is it block walls for everything internal? Because that's going to affect the signal source differently than if it's your standard drywall construction. And then most importantly, all of the local carrier signals. We get that back, then we will turn around a full heat map for you. Now, we technically do this on buildings over 25,000 square feet. That's just a given. We will, turn one of these things around for you pretty quick. But if you need it for a smaller facility, just put in the notes. Please provide IB Wave design for us, and we'll knock that out for you too. But along with the IB Wave design, the heat map, we also get the indoor coverage plan or our design plan. So this design plan gives us all our link budgets. It shows us exactly what cable goes to what accessory, how they're installed. So you'll be able to really lay this thing out pretty for simplicity factor. It just helps with the overall installation. Now, please note that there are a lot of times that we don't know where those cable pathways are at. So we're going to do it based off just our basic judgment on it. And then you might have to make some slight adjustments on the fly. But if you have any questions on it, feel free to call our design team. They'll be more than willing to help you. The question everybody's been asking, what cables do we use? Can we use RG6? You can absolutely use RG6. Just keep in mind that you're losing about 10 dB every 100 feet. And I know the reason why we ask these questions is if you are doing any residential, especially existing homes everybody's cut the cord at this point in time, right? So everybody's utilizing streaming services. There is a lot of RG6 in the walls unused. You can go through and use that all you want. Keep in mind that you can't have any of the TV splitters that are in place there. So you're really going to have to trace those cables to make sure they don't go through them. And if they do, we'll just have to get some couplers or combiners and put the cable back together again. Just remove that. But you can absolutely use that all day long. Oh, that's a good question. I think you're right around 4.5 dB for those 5/8 inch firewalls that are out there. Yes, 7/8 inch with DIN connectors. What do you mean by that, Andy? Type that back in there for me for what you're saying there. 7/8 inch with DIN connectors. If you're stating that, yes, it has an F connect. Oh, yes. Oh, God knows. 7/8 inch. You need a horse to pull that through a building. Oh no, I'm out. Sorry. One thing to keep in mind, which did remind me, Andy, is all of our boosters and antennas have N-type connectors. All of them do. Our RG6 or any RG6 has an F-type connector, so it's a 75 ohm cable. You do need to purchase adapters, an N to an F adapter, to be able to utilize existing RG6. But hopefully we're not using RG6, especially in the commercial spaces here. 400 series comes with most of our kits. 400 series is great up to about 100 feet in total length. It's not 100 feet to an antenna and then another 100 feet, because you are going to lose way too much signal. Again, you're losing about 7 dB in those 1900 and 2100 megahertz. The booster only has 17 dBm of output power, of downlink power. So right out the bat, if you run the cable that long, you're hurting the performance of the system. So how do we get around that? You go to half-inch cable or a 600 series cable, and now I think RFS probably makes some of the best half-inch cable in the marketplace. It's carried by all of our channel partners. I would encourage you to utilize that cable for your major trunk runs. So anything that's going to go even up to 100 feet, it just provides better. It's your lifeline. That's where all the blood's pumping through. So just use the 400 series as little whips to go out to your antennas. That's just my opinion. But you can see the performance difference on it. I mean, the half-inch or 600 series cable on those lower frequencies, I'm only losing a dB and a half, so I can stretch the full runs much, much further down the road as needed here. There are a number of different types of antennas. Really, there's only two. There is an omni style antenna for both indoor and outdoor, and there is a directional style antenna. Now, when I look at the different antenna types, keep in mind that our dome antennas are great up to about 25 feet. And the reason for that is they go out about 60 feet outward, but they don't go down very far. I mean, 25 feet is still pretty far, but it doesn't go down any further than that. So if you had a warehouse scenario or a high open ceiling and they're 35-foot ceilings, you're going to want to use a panel up in those ceilings versus a dome. Just going to give you better performance. When I look at my antennas and my placement, we always have to be cognizant of oscillation. This is the biggest deterrent to a lot of people when it comes down to DAS, because not only is capacity, until now, it was kind of the unknown ghost in the wires. We didn't know why it wasn't working. Oscillation is when your outdoor and your indoor antennas are talking to each other. So one bit of advice, the towers on the left or the west side of this building, right? We want to make sure, or we want to try and get our donor antennas as far over to that left side of the building as possible and point those antennas up and away from the building. So you don't want to go over here and put your Yagi on this side and shoot it across the overtop of the building. I know in a lot of commercial buildings, there's no way around that just because of where the antenna will, where the roof penetration might be. And unless you're using fiber and you don't want to run copper that far, if you do have to do this, get it on like a 10-foot pole and non-penetrating roof mount, like a sled, get that thing 10 feet up in the air and then angle it like a 15-degree kind of angle towards that tower. The reason for that is it comes out at such a small spread that if you get it high enough and you angle it up, it's going to get up past the roof for you so you don't run into the problems of oscillation. But this is the best practice I could urge you towards, especially if the tower is off to the left, point the antennas away from the building. And that separation will give you plenty of, you won't run into that oscillation issue anymore. So please keep that in mind. Wall mount antenna, good question, Thomas. So a wall mount antenna for us, those antennas shoot up to 90 feet away. So they're really designed, but they come out at a narrower beam width, right? So if you're on a wall like option B here on the picture, that device is going to shoot further than an omni antenna would. That's why we use it up in the ceiling grids in that scenario. Big open spaces, gymnasiums, we put these things on the walls and it covers an entire basketball arena in schools, and they work very, very well. Very high power solutions. Sorry, guys, hold on one second here. All right, there we go. So installation and optimization of the system, this just comes down, we call it the A through E method. I would encourage you, if you're doing your own self-installs or if you're farming out to somebody else, come up with a procedure that would ensure that there are some spot checks. We call it the A through E method, and it's very simple. You're going to use one of our meters, and you're going to have some attenuators with it that you're going to use for the latter portion of this test. So starting point is we're going to be up on the roof, and you're going to have the donor antenna connected directly to the meter. And I would just use mode 3 for an example here. In mode 3, 1900 megahertz, I'm at a -70. If I have 100 feet of cable coming from that roof down into the booster, right before you connect to the booster, reconnect that cable now that comes from your donor. And at 100 feet, 400 series cable, 1900 megahertz, I should lose around 6 dB, give or take a few, but I should be right around a neg 76. If I'm at a neg 90, something's wrong with the cable. We know the antenna's working because we just tested that, but something's gonna be wrong with the cable itself. So go through, cut off the connectors, re-terminate it, and that should fix your problem. When we get from the booster side down, this is where we have to put our attenuators on it. 'Cause if I don't, not only could it screw up the crystals on the inside of it because there's just a lot of power going into it, it's going to tell you max gain. And max gain isn't something that we can utilize for a mathematical equation standpoint. So with my 40 dBs of attenuation on it, mode 3, 1900 meg, I should see right out of the booster, I should see about a neg 45, roughly. And we're just going to do that same math. In this scenario here, we have a two-way splitter, which loses 3 dB. I've got 100 feet of 400 series cable. So out of that splitter, I should see about a neg 54, the minus 3 dB, and then the minus 6 from the cable itself. So I should see right around that neg 54. If not, could be a splitter, could be the cabling. And we're just going to do that all the way down the line. And you just see the math just gets bigger and bigger for us. And then finally, we want to just test the output at the server antenna or the indoor antenna site. Now, one thing to keep in mind, there is something that's called free space path loss. If you are directly under the antenna, you're going to see something probably around the neg 50 output, neg 60 maybe. As you get further away from the antenna, it drops off drastically. You'll see 20 feet away from that antenna, you're probably going to see, you're going to lose anywhere up to neg 50 off of it. So you could be at a neg 50 under the antenna, and then you're at like a neg 100, 20 feet away from the thing on an RSSI standpoint, which is outside of the realm of usability. But because there's a power relation coming in here, it still works. So don't get too far away from the antenna and go, oh my God, it doesn't work for me. It's still the power is still there, but I just want to make you aware that free space path loss can make it look like the system isn't working. So keep that in mind when you walk away from the booster itself. Now, when I install and we're optimizing the system, we can combine a number of products together. So I can utilize it from a donor antenna standpoint and feed up to 4 boosters internally. But it's all going to come down to what type of components we're going to use. Our couplers are unbalanced, meaning that it's passed through on the input and the output side of it. The only loss we see is on that side port. So I'm either going to have a 6, 10, 15, I believe we even have a 20 dB attenuator or coupler now, but those are going to help you extend your coverage down a line a little bit longer. Splitters are all balanced. So you have that 2 dB loss on a two-way splitter, 3+ on the three-way, and it gets up to almost 6 on the four-way. But each port has that same amount of loss associated with it. So it's important to kind of understand, how do we optimize a system to ensure that the coverage down the line is close to the antenna that we have at the very beginning. So 30 feet away, that first antenna, by utilizing a 6 dB coupler, I should see about a neg 47 typically coming out of that system. The next antenna I go to, we have a little bit longer cable run, maybe another 30 to 50 feet away. You've got a neg 50 coming out of that antenna. And then as I get very far, the last antenna, you've actually got a stronger signal than the one closer, typically because we're running it through where there's no loss. So we can balance that out. And, a three-way splitter, you're going to see the same amount of loss going down the line. In a lot of cases, in this scenario here, I should say, it's like a long hallway, right? Very easy, just one run going down, and you're kind of hitting them all like in a school or an office space. There are instances in an office space where maybe the IT closet's in the middle of the room. Now you got to go out to 3 different antennas. There's no way around it. This is the only way to do it, unless you're utilizing like the fiber system or a system with multiple outputs on it. So this is one way of kind of looking at how that scenario is going to really treat your customer. So a neg 48 for the closest antenna is probably going to show 4 bars, and neg 53, even though it's close, might show 3 bars. Still the same performance, you're still same call quality, but your bars are going to shift just a little bit. And then there's other instances where we use one combiner, or I'm sorry, a coupler to go to your first antenna, and then maybe you split on the left and right down the road to two other antennas through a two-way. This is where there's nothing cookie cutter about it. Everything's going to be a little bit different. The components are going to stay the same, but you're going to add, mix and match in different scenarios. It's where our design team really, really comes into play. Any questions on that scenario there? I didn't see any. I think we answered all the questions about the meter and the power, I'm sorry, the cabling side of it. All right. Your last step is commissioning. You have to register the systems with the carrier. It's very easy to do. You're going to go to their websites. You're going to type in the customer's name. So what it be a business name, contact phone number for that customer, and then the make, model, serial number for that solution itself, data was installed. You hit submit, you get a little piece of paper back that says, thank you for submitting this. And honestly, I don't think the carriers do anything with it, but some will go and post those DAS systems like we saw in the cell mapper. So this is something, honestly, it's required by the end user is responsible for it. But this is something that I think, if you're doing all the work, you might as well commission it for them and do the full commissioning and then hand them all the paperwork and say, thank you very much. So troubleshooting a system, once we get it installed, is pretty simple. All of our legacy boosters have some type of either dip switch, gain control, or light sequence that tells you what to do. All of our new product is all done via Bluetooth app. So it's the new stuff is way easier to use than the old stuff that's out there. But because we do have a lot of legacy products that are still being sold, I just want to quickly go over this. Any flashing green, solid green, or flashing yellow lights on any of our boosters are 100% normal. That just means that there's some type of automatic gain control kicking in. Flashing yellow and red, that means we're oscillating. The only way to fix oscillation is to increase the distance from your donor antenna to your indoor antennas. Flashing red, I have not seen in probably 10 years now. So that flashing red is just some things that overpower too strong of a signal coming in. It's a good question. So if we use the meter and measurements are all the same, but the customer doesn't see any bars increase on their phone, typically I don't see that happen very often. There's some type of an increase. What I would probably do at that point is I would go through and I'd put their phone into a test mode, turn the system off, get a reading, that RSRP number, and then turn it back on and see what that RSRP number is. Bars on a phone it's a placebo effect. There's different algorithms for different carriers, different phone manufacturers, although they're pretty legit. I mean, if you have 5 bars, you got great service. You have 1 bar, it's usable, maybe. But I would go that route, is put their phone into a test mode. And then if they're still having issues, more than likely, well, I should say this, when you're in test mode, there's something that all the phones will show you. It's called a PCI. Excuse me. And PCI is the identifier for what tower you're actually connected to. And if you go to cellmapper.net, you can actually see the PCI. You know what? Let me go back to that really quick, because I think that's an important thing to show. I'm glad you brought that up here. So the PCI, when you click on a tower, is right here. Where did they put it? Let me see here. Here, PCI right here. So that PCI is the fingerprint that your phone will actually show you. So if I go in a PCI on my phone right now, let me just see what I can come up with. So my PCI on AT&T says that I am on 148. So where the heck is 148 for me? There's 16. $358, $378. No, I just switched to 111. So I'm actually on 111. So I went from band, well, now I'm on 5G. So it's bouncing all over the place. But my frequency right now, so I'm actually on this tower for AT&T. So the one that we originally said with the parking garage, this is the tower that I'm bouncing off of right now. So it's a great way to be able to just inspect. So let's just say AT&T was the only person that was having a constraint on it. And yeah, no, good idea. So when I look at the to go back to his question is they don't see the bars increase on the phone. You could have an alignment issue. And if they're only really worried about AT&T, that PCI in test mode is going to help us identify that if we were pointing northwest to the Verizon and T-Mobile towers in that scenario on Cell Mapper, we would have to realign that donor antenna to AT&T. So more than likely, that would be the main issue, that it sees because of the frequencies and bands are so similar in the carrier's network. This allows us then to ensure that we're just pulling in that AT&T, or we're benefiting AT&T more than the other carriers. But more than likely, that's the reason why you would still be having some constraints out there. If it's not, and we're still having issues, that's where tech support really comes into play, and they will dive in, especially if you're on any of these new boosters with the cloud. They can see everything that's happening. If there's maybe we are having some more, it doesn't go into full oscillation, but we're still detuning the booster to a point that it just isn't advantageous for our cell phones to take advantage of it. And that's something they can see in their kind of viewing screen as to how that system's performing. I think that's another way of looking at it. Like right now where I'm at a neg 103 on that tower, which I bet you I can see the tower from, well, anyways, I don't want to, it's like a squirrel moment for me. Watch out. Watch out. What metric are the bars and the cell phones actually representing? It's an algorithm, Ethan. There isn't, they have a rhyme and a reason for this thing here. Actually, if I pull this up for you. Versus. So there is a great article out there that, let me just show you this. These are the conversations I love getting into, guys, because this is the stuff that your customers, this is real world scenario here, right? So this is a website, and I'll go back. It's a digi.com that has this. But for 4G, neg 95, neg 85, anything better than neg 85 gives you 5 bars. And when I get down into your 2 bars, this is almost, it's still usable coverage in RSRP. Anything worse than this is where it falls apart. Neg 115 to 199 is 1 to 0 bars. At a neg 125, you technically can't use your phone anymore. So this is where the bars in the phone don't help us whatsoever. And that, these are pretty good. Having a 10 dB gap between them, that's pretty realistic. When you get into, and that's just the power, then you get into RSS. When you start getting the SINAR built into this thing here, and that changes everything. So this site was Digi International, Cellular Signal Quality Explained. Good deal. Great question, guys. All right, so when I get past some of the digital attenuation, again, red lights on multiple bands, I only bring it up because there may be some legacy customers that have product installed that have red lights flashing on the thing. And if you walk in, go, well, something's wrong with it. It's too much power. Maybe a tower was put up a couple years later, down, right next to their property. And if you've got red flashing, the only way to get rid of the red flashing is to detune the system. So we either go from a Yagi antenna to an Omni, or you add attenuators to it till we cool that signal down. Again, I would say any booster older than 6 years old probably could have that problem that's out there. More than likely they would. Yeah, I can do that right now for you. Give me a second. I'm going to put that link for that Digi into the chat box here for everybody. So you guys can have that now. So a lot of customers too will call up and say, hey, my booster just isn't working. And, why is this thing not performing the way it is? Sometimes we get our integrator partners that are calling, our channel partners. Some of these things we already understand, and we've worked through it. We know the outside signal's not too weak. We've done the A through E method, and we don't have too long cable runs. We know our connectors are on there properly. It just comes down to, I think we have less than a 1% defective rate on our booster solutions. So we just have to make sure that we're when we go through the system itself, that if they're having these types of problems, we just don't see it. One, just make sure your input and output are on the right side. That happens once in a while. But two, that's where our tech support team is really going to come into play. They're really good at identifying it. I only have one job right now. Again, even with my Wilson electronic days, I think I have two total jobs that we just couldn't get to work. And I have one job right now that's just being difficult, but a it's a signal noise issue. Everything else works very, very well. The bands for the new meter, the new Bluetooth meter that we're coming out with, it'll encompass everything. But it also saves a lot of things to the cloud, and there's a Bluetooth app. It's pretty slick. So it's still in development. I think we've got our final test product out there. I don't have a cost associated to it yet, but I think that it's going to be right around $1,000, I think. So it's not horrible, but it's also not the cheapest thing. So how do we troubleshoot if somebody has maybe a more rural area and they've got an Omni antenna outside? They show great bars, but kind of going back to your question here, I have good bars, but I just can't make a phone call. That's an uplink issue. That's where your phone just isn't strong enough, or even in this case, the booster is just utilizing an Omni antenna, kind of like a lantern, and we're just trying to pull whatever we can in. So we would simply switch that out to a Yagi antenna and make sure we point it towards those donor sites that are out there. If we have an issue where the system's performing except for one antenna, that's just A through E method. You just got to go through and test it. And I know it's time consuming at times, especially if you got to get lifts involved. But that's where doing this while you're doing the install is so important, because you can really find the pitfalls before you put everything away and say, I'm done. Let's go back to let's hand it off to the customer. But testing that is going to be the best way of doing it. Now, there are instances as well where we just have zero control. And in your manner too, there's a lot of things you can't control. And that comes down to the carrier's antics and what they're out there doing. So the booster used to work fine, all of a sudden it doesn't. More than likely, the carriers have decommissioned that tower, or they moved the tower antennas completely. Maybe they change antennas. If it's over a course of time, we could have weather or broken cables that are out there too. So some of this stuff, an annual inspection is important. I would build that into any type of service contract. Most of our partners, honestly, in an annual site, anywhere between $1,500 to $6,000. Just depends on the size and scope of the building. But include the site cert, the kind of walkthrough or site visit. You get them the management side of it, some remote managing, cloud management included in that, and the cost comes, for them over the course of a year, really isn't that much money for them. So next steps for us is to get that certification test. So I will get you a link to that test as soon as we get off this training here. And if you want to learn more about SureCall, you can go to YouTube and type in SureCall University or just SureCall. And we've got everything on there, from basic RF terms to how to use a signal meter, to what is active versus passive DAS. There's a lot of great things that are on there. This training will also be on there shortly. But it's the main key takeaways. Just make sure that you understand that our solutions will enhance coverage for any carrier in North America, and they're compatible with every 5G device that's out there, regardless if they're put in a 5G system or just a 4G LTE system. Our product will work for any device because all the devices work backwards. When you're looking at manufacturers and boosters, make sure they're FCC and carrier approved, specifically Part 20. It's an important thing to be able to tell the customer that you're installing a legal booster. Extended range technology is a technology derived from our carrier partners. It's really the way of the future for us. Take advantage of our design services, and then feel free to reach out to us, myself directly, or any of our partners here online moving forward. And I tell you, it'll definitely help, kind of, especially the first couple installs you're doing. The product's very simple. The software does everything for you. As long as we're installing it correctly, the product will work. Yep, ADI has it, Graybar, Accutech, Tesco, Tally. We have regional partners that are out there, there's not that many of them, but there's enough out there that can get you the product as well. So no, none of our partners stock it. Not very many of our partners stock it. They all drop ship. So we ship out of California. And yeah, Gord Austin. Let me get you Gord Austin's contact information here. Give me 1 second. Gord Austin is our Canadian country manager. I'm gonna put Gord in this. So for our Canadian partners, this is Gord's phone number. And then his email address is even easier. It's just gord@surecall.com. He's based out of Toronto. And it's similar, same but different, right? Um, our product, our new meter. If anybody here is used to the Wilson meter, the Wilson Pro meter, it's a different format and it runs solely on the web itself. So in our cloud solution, so it's pretty unique in how it's going to capture a lot of the information that our meters currently just miss. So it's a pretty unique solution for us. Very unique one. Absolutely. Good deal.